this is actually two talks kind of pieced together. So I didn't really know what the level of experience was with people coming to the talk. So what I've done is given a sort of top level introduction to AWS. So if you've never come to it, if you don't even know what it is, it will give you an idea of the, what sort of services are available. And then the second part is the sort of more technical part. So we'll look at web architectures with AWS, because there's a number of ways you can architect stuff. So that's the kind of the split. So just a little bit about my background. I've started off in video games. I'm an old guy, I've been around forever. So I've been working with AWS for about 7 years. So that's probably the most relevant part. And like Luke said, I'm a DevOps engineer now locally at Capgemini. So we're working for HMRC. So yeah, that's the split. We'll cover Amazon Web Services sort of a very top level, and then we'll dive into architectures. So the way the architecture will work is we'll take like a classic LAMP stack, which everybody knows, it's the most familiar stack in the world, and we'll look at how you would apply that in AWS, and then how you might iterate on that architecture to use some of the more interesting sort of modern technologies available. So we'll look at sort of containers and then serverless as well. So that's the plan, and hopefully some Q&A at the end, so if you've got any questions. So get your bingo cards ready. There's a lot of buzzwords going to fly around. If you've not come across any of this, then hopefully we'll cover it somewhere along the line. If not, it's going to come up at some point, because Amazon covers a lot of bases. So we'll start with something we all know is Amazon. Like, Amazon is just this enormous company. They've been around for a long, long time. Pretty much invented e-commerce, and they've been going since 1995, and in fact, when they opened, they look like that, which is, if anyone has been around for a while, they'll recognize that gray. So yeah, they're literally a very, very early part of the web. But web services are kind of a side product of what they do, because when they sold, they're a shop. But what they found was they had a ton of infrastructure that wasn't being used for most of the year. So if you consider like Amazon's business model, they'll probably shift a lot of units at Christmas. So in order to make sure that the website stays up, they have a ton of infrastructure supporting that. But a lot of that's dormant because they have to cope with the peaks of Christmas. So what the idea was with web services, were they going to lease off or rent out some of that infrastructure through the year? So that was the original business model. Just quickly scope what web services are. I'm sure you know this, but it's any sort of web-based managed service. You could think of Gmail, Dropbox, any of these things are examples of that sort of thing. The key part, really, I'm going to sort of drop in a few things I sort of realized along the way. There's different levels of responsibility. So Amazon are going to take care of a bunch of things for you, and you're going to take care of a bunch of things on your side. And there's this notion of a shared responsibility model. So although Amazon will take care of certain services, you need to make sure that you're doing your part, otherwise your infrastructure is not going to be safe or compliant or whatever. And there's a number of terms have sprung up around this. So if you know, you've probably come across as as a service, something as a service, software as a service, infrastructure as a service. Just to try and sort of make sense of that, it's down to this level of responsibility and level of control. So something like software as a service could be pretty much anything like Google Docs is an example of that, or Wix or ShareSpace. You are not responsible for any of it. You don't manage it. You log in, you do whatever it is you do with that particular tool, and then you go away again. The next sort of step in that is platform as a service. That will be probably what you're used to with typical web hosting, something like that. So you're responsible for taking your HTML, JavaScript, whatever files you've got, and you manage that sort of part of it, but the platform will manage the operating systems and the hardware and all of the kind of bits underneath that to make sure that your website is being hosted. So the next one down is infrastructure as a service. So essentially you deal with the same things you were dealing with before, but you're also managing the operating system at this point as well. So you need to make sure that you're patching all of your web servers and all of that kind of thing. So it's down to control versus responsibility. Sometimes you don't need that level of control, and you don't need the kind of things that these services are offering, but sometimes you do. So depending on how complex your web requirements are. Quick look at infrastructure as a service. There's loads and loads of companies doing it, but the three largest ones are Amazon, Google, and Microsoft with Azure. And they're they all have competing products, but they're also enormous ecosystems in themselves. So we're only going to look at AWS today, but you can imagine that these services are also available on the other providers too. So, so out of the gate, when AWS was first conceived in 2002, it was essentially an API into what Amazon produced, which was, you know, selling books or products or that kind of thing. So it's actually entirely different to what we know it today. If you look at what the sort of services they're looking at, they're really just APIs into the data that Amazon are holding on products and books and stuff. So it actually got reinvented a few years down the line. So in 2006, it's a little bit closer to what we know now. They relaunched it and released 3 products. So out of the gate, SQS was the first. That's a queuing system. So if you've ever sort of used any kind of managed queue, RabbitMQ or anything along those sort of lines, that's what that was. It's a managed queuing system. Second one was S3, which is simple storage service. So that's a managed sort of data hosting. Imagine it like a huge hard drive that you can fill up indefinitely. And EC2, which is Elastic Compute Cloud. So this is their form of spinning up a virtual machine, and you can put a web server or whatever you like on that virtual machine. So those were the 3 services out of the gate. And they bring on new services all the time, to the point where in 2020, there's actually a search box on the services page because there's so many of them now. There's like about 100 services. So these are the ones you'll most commonly use. And these are not actually services, these are groups of services. So just to sort of clarify what those are, compute is obviously some way of performing computation online. So that will be virtual machines, containers, that kind of stuff. Storage is S3, like I mentioned earlier on, and various other kinds of things like Glacier, which is sort of longer term storage, different types of storage, different types of databases. So you've got SQL databases, you know, well, actually we'll get into that later on, but lots of different types of databases as well. Networking, which is how you get a bit of private networking of your own and you stitch it all together. And security is a suite of tools that essentially make sure that you are secure, compliant, that kind of thing. Having said that, there are dozens and dozens of services. So all of these are groups of other services that you may use in your architecture, whatever it is you're building. You might use mobile, machine learning, any of these kind of things as well, in addition to all the other stuff. So essentially there is a tool or service out there for 99% of the thing that you would want to do. But the key part really in getting your head around it, because it's overwhelming, there's an awful lot of services there, is that they're modular. So the way to think about that is that there are no external dependencies between these services. So if you have a service like S3, then S3 has an API and it is self-contained. And then if you wanted to use another service like EC2, then that has its own set of APIs as well. So it's a little bit of building blocks. You take the services that you need, you stitch them together, and that's how you make sense of it. So the interesting thing about Amazon in particular is that they take this to an extreme. So not only are the web services, all the services you've seen there, modular, but Amazon itself is built in that way too. So yeah, so I've explained what the API is, but essentially Amazon kind of pioneered this notion of a 2-pizza team. So the idea is that the team that builds that service runs that service, and it is a very small team. It's enough team you can feed with 2 pizzas. But also each service is self-contained. It has no external dependencies out of those other services that you've seen, and it exposes an API. But also it takes it one step further, and all of Amazon is essentially the same. There was an interesting memo Jeff Bezos put out in 2002, essentially saying that every part of Amazon is modular and self-contained. So it leads to this tweet, which I thought was quite interesting. Amazon is this machine that makes machines. It's built in a way where everything is modular and everything talks to everything else and everything is interdependent. But it can essentially build and build and build. And this is why we're getting so many of these different services. Okay, so I'm going to jump into architectures. So this is really just to show you examples of how you would stitch all of those different services together. So we'll take something that hopefully everyone's relatively familiar with. It's the LAMP stack, which has been around since the beginning of the web. It's Apache, Linux, MySQL, PHP. So Apache is your operating system. Apache is your web server. Linux is the operating system. SQL, MySQL is your database, and PHP is what's running your sort of client side, your server side code. So if you built an application with this, something like WordPress, something that you'd be familiar with, the developer, can you see my mouse? Yeah, big thumb. Yeah, okay. So the developer does some local development, and when they're finished with it, you would take those files and put them onto a shared server somewhere. So it will be something along the lines of the files from here, put on the shared server, and that server is already running the LAMP stack. Then you would add a DNS entry somewhere. So that DNS points to your shared server somewhere on the internet, and that's it, you're live, your website is live. So that's how classic web hosting works. Let's have a quick look at how that would work in AWS. So the first thing you'll realize if you start, you have a brand new Amazon Web Services account, you'll go in and you have no web servers, or you have no servers at all. What you get is a little piece of virtual private networking. Essentially, they call it a VPC, or a virtual private cloud. So that is yours. That's allocated to you, and there's the only other thing it comes with is this thing called an internet gateway. So the idea is that you can configure the networking of your little private area of networking, and if you wanted that connected to the internet, you would route traffic in here out to the internet. So, but first thing you'll realize, obviously, that there's nothing there to route. There's nothing going on inside that virtual private cloud. So a little bit about scale. So your private network will be in a region somewhere. We're in the UK, so there's a region in London. There's also regions all over the world, and there's new regions coming online all the time. Each region gets given availability zones. So an availability zone, you can think of it a bit like a data center. It's a physically discrete location. Sometimes it's multiple data centers, but essentially you can think of it as physical locations within a region. So if we're in London, there will be 3 sets of data centers in London, 3 availability zones. There'll be ABC. Your virtual private cloud has access to all of those. So you can spin up a virtual machine in any of those availability zones, A, B, or C. You can also partition that virtual private cloud into public subnets, private subnets. Essentially, subnet, the difference between a public and a private one is it has access to the internet or doesn't have access to the internet. So there's lots of use cases for that, but we'll kind of get into that in a minute. But that's some of the sort of VPC architecture stuff that we'll get into. The subnets have routing tables which say where traffic goes, and you can have an internet gateway out to the internet or VPN gateway as well. If you have a data center somewhere, then you can have a connection that's private to you, routed out. So there's lots of ways to architect your VPC, and it depends on the scale that you're working at and what kind of thing that you actually want to do with it. So anyway, out the box, that's what you get. So we would like to put our web server in here. So first thing we're going to need is a web server. So servers are, we're looking at EC2, this thing I mentioned, it's been around for a long, long time. The way that works is you just pick from a selection of offerings they have. They call them instance types, and that's a mixture of CPU, memory, network I/O, that kind of thing. So it's a machine profile. Then you pick an operating system, typically Linux or Windows, and then you decide where you want to put it. So if I want to bring up something in London in any of the availability zones, I'll pick one of those. And then you give it a bunch of firewall rules. So these are called security groups. So the idea behind it is you bring up an instance, and a security group is a collection of firewall rules that you can apply to that instance or to multiple instances. So the firewall rules, just an example of that would be something like, if it's a web server, you'll need port 80 and port 443 if you want to get to HTTP and HTTPS. You may want to SSH into that box if it's a Linux box to do some work on it. So you may allow port 22 to be accessible from your own IP. So that way it's only you can get into it. And yeah, 80 and 443 will be open to the world. So that's kind of a classic sort of web server security group. And then you would pop that in there, bring up your instance, assign that security group, and then you're good to go. So the way that would work is your EC2 instance comes up. So this is our Linux box. And it gets given, if you route it to the internet, it gets given a DNS entry out of the box, and it looks like that. So obviously that's not great because you don't want to be sending that kind of URL around for your website. You maybe want something a little bit prettier. Oh, actually, that's a good point. So when it comes up, it has your version of Linux on it, but that's all. So you are also in charge of making sure it has PHP, it has MySQL, it has all of the other things that you would have expected to have. So you would be expected to install these on that box. Right, so we want to give it a DNS entry like in the last time. So there's a service for that. It's called Route 53, and it handles public and private DNS, supports IP4, IP6, all of that kind of stuff, and does a whole bunch of other interesting stuff too. So, but really all we want to do in this case is just assign a DNS entry for our IP address for this box here. So we now type in www.example.com, and then we will see our web server. So you probably, that's the equivalent of the thing that we did earlier on, but done in sort of the Amazon way. Right, first thing you might want to think about is HTTP, and this is 2020, so we should really have that as HTTPS. So you want an SSL certificate on there. It turns out that given this current architecture here, you think there'd be a service for that, but actually there is a service, but we'll get into that later on, but it doesn't really work that way with this architecture. So you would put something like Let's Encrypt in there, and that would allow you to go to HTTPS. Right, so the next thing you want to do is start thinking about how we can improve that architecture. And my suggestion first would be that this is a little bit fragile. Everything, one instance of everything sitting on one box is, it's all your eggs in one basket. So there's a sensible way to do this. You would like to split the app from the database. So that is essentially taking this MySQL part and then putting it somewhere else. So allow you to have a little bit of redundancy. So if the app goes down, then maybe the database is still running. First thought you might have would be something like this. You bring up another instance, Linux, you put MySQL in here, and then you would have your app separated from your database, that's all good. But given that it's Amazon, there's obviously another way of doing it. There's a service that deals with databases. So all the usual suspects are here, even the really expensive ones if you want to kind of splash on Oracle or something like that. But these are relational databases, but there's all sorts of other crazy toys as well. If you are building something else other than something, I'm giving you some basic examples here, but there's lots of dedicated databases for doing stuff like, say, time series or even blockchain and that kind of stuff. So you may have use cases that are specific, but you may find that there's actually a database designed for that purpose. And these kind of things are great once you get into sort of larger web apps or more sophisticated applications. So yeah, you spin up the databases you want. And what's lovely, I think, is it's a managed database. It's somebody else is making sure that this thing stays up. It's being replicated. You don't lose your data. There's a lot of trust in those services actually just going to be there, and you don't have to deal with it anymore. So anyways, we'll take a MySQL version of RDS. And there you go, we've improved our architecture already. So the next part, I think, will be jumping to observability. This is something that's, as these things become more complex, as you sort of piece more parts together, you'll realize that you need to have some sense of what on earth is going on. because it's very easy to scale very, very, very fast or get very, very big, and just the general sort of metrics and logs and those sort of things become unwieldy after a while. So AWS has a service or a number of services for this. The typical one that's used is CloudWatch. And what that does is it centralizes all the logs and metrics for all of the events that AWS produces. So that will be, if you spin up an EC2 instance, then it'll get some logs into it. If you do anything, any activity in S3, any activity across the AWS network will end up in there. And you can look at those logs and then apply metrics to them. And then on the back of the metrics, you can have events fire. So you can get quite sophisticated with some of the stuff that's here. It is still a minefield, and it's incredibly complicated. And there are whole products designed to make CloudWatch a bit more understandable. But essentially, that's the built-in service. I've not tied it to anything, because essentially CloudWatch talks to everything. So I assume that has tendrils into everything that you can see here. Right. The first thing I would suggest to improve the architecture again would be to put a replica to your database. So instead of having a single database, you want some kind of failover. So if the database has problems, and that could happen, it's unlikely to happen, but it could happen, then you've got some kind of level of redundancy. So the next thing is our wonderful app is getting some traffic. Maybe Hacker News is just, it's been on the front page, and all of a sudden it's getting like a denial of service attack. It's really struggling. So we need to look at ways of scaling that app based on just levels of traffic coming towards it. So classic way to do that is put a load balancer in front of it. The usual suspects are here. You've got a network load balancer, an application load balancer. You pick the one you like. This is in front of EC2. So imagine the traffic coming here, traffic coming into the internet, and it's immediately hitting this one instance here. What the load balancer can do is it will take the traffic coming in and essentially round robin, or any other, there's a number of patterns, but you can have multiple instances here. And then the traffic is shared between the instances, and then you're more likely to have a responsive web server. So life is good. We're back to good there. The other thing to do is EC2 will also do a thing called auto scaling. So the way that works is your CloudWatch metrics, everything that is coming from EC2 or from the load balancer, you get a bunch of logs into here. And based on those logs, you get some metrics. And on the metrics, you can set an event to say, oh my God, we're being drowned with traffic. Do something about it. And that can be something like add another instance of our web server to the auto scaling group. And then that will just ramp up as many servers as you need to cope with the traffic. When the traffic goes down, you have a similar metric that goes, right, bring those back down again. And all of that can be happening while you're sleeping, essentially. You're not getting a phone call or pager duty or something horrendous to deal with that problem. So that's auto scaling. The advantage as well of having a load balancer is you can integrate it with a thing called Certificate Manager. So I said earlier on about having Let's Encrypt. There is a service that does the same kind of thing for SSL certificates, and it's called Certificate Manager. It's free, doesn't cost anything. It rotates the certificates for you. It does all sorts of great stuff. You just switch it on. Once you've configured it, you never really have to worry about it again. So in this case, so the HTTPS calls coming in here, the HTTPS termination will happen on the load balancer. Certificate Manager will make sure that your certs are up to date. And then at that point, then the traffic goes through to your instances. So you really don't have to deal with HTTPS at that point, unless you particularly want to have secure traffic inside. And, there's reasons you may want that as well. So that's all good. Again, these are things that you can essentially automate away, which are normally big problems if you're having a hand roll. So the other thing you can do to try and sort of make your web services, your web servers a bit more performant, is take some of the grunt work away. So a classic example of that is static content. So things like flat files, anything that's not being dynamically generated. So that could be HTML, JavaScript, images, anything that's just not being generated on the fly. You want to serve that from somewhere else, a CDN of some sort. So the way that works in AWS is you have an S3 bucket, as they're called. So that's those things we're talking about. You store all your flat images, flat services, flat files in there, and the CDN is called CloudFront. So you would give that a DNS entry, something like cdn.myexample.com. So now what's going to happen is traffic coming into your web server here, that's going to be doing WordPress stuff. It'll be doing whatever it is that your app does. But anything that's a flat file can be served from somewhere else. The beauty of this kind of stuff is you can get all sorts of caching. You can have it routed so that it's served from the nearest geographical location. So if you are in the States, then a copy of any of the flat files that are in this bucket will be sitting in a server in the States. So you'll get really, really quick responses on those as well. So that's great. And also it takes a bit of load off of these instances as well. So that's great. That's kind of a pretty modern architecture. But then somebody on your dev team goes, aha, containers, they've discovered Docker and Kubernetes and want to go that road. So let's take this architecture and evolve it for that. So I presume everyone knows the difference between a container and a VM, but I'll kind of quickly explain it. Essentially, a container is a lighter version than a VM. A VM is a virtualized machine, so it virtualizes not just the operating system, but also everything else that's going on in the machine itself. So a container is much lighter. It just really virtualizes the parts of your application, and it's the beauty of a container is it's really portable, so it's really light, whereas virtual machines are a little bit more unwieldy. So there's obviously services for everything, but there's a thing called ECS, which is the Elastic Container Service. It's a bit like EC2, but it's for running Docker images. So in the case of EC2, you've got what's called an AMI, an Amazon Machine Image, and that's a virtual machine. And this is going to do exactly the same kind of thing, but it's going to do it for a Docker image, which is a bit lighter. Kubernetes is an open source kind of Google project, which is for managing containers. It's a container manager, I guess, is a good way of thinking about it. AWS have a service for that they call, which is ECS for Kubernetes. So it's essentially managed Kubernetes, if you can get your head around that level of abstraction. And then there's the other thing that will be used is the Elastic Container Registry, which is a bit like Docker Hub, if you've kind of used that. So it's just a registry, a bit like GitHub for containers is another way to think about it. So the way that would work is our EC2 instances would go. We're no longer using virtual machines. We're using this Elastic Container Service. Now this is you're no longer responsible for EC2. I talked earlier about shared responsibility. This is a good example of that. In a situation like EC2, you're responsible for patching patching your Ubuntu or whatever it is that you're running it on. In the case of the container service, that doesn't live inside your VPC. That's run in Amazon's responsibility, Amazon's world. So they will run your containers, but they'll run it inside their own infrastructure. You can still have the auto scaling in front of it. So you can have it listen to traffic and then spin up more pods, more containers for you to deal with traffic. So it works in much the same kind of manner, and it can still talk to the databases over here. The images are coming from the ECR, or they could come from Docker Hub too. There's no reason why it couldn't come from there. But yeah, in case of Amazon's offering, it would be this ECR. And then, yeah, so the next part will be if your app has been very, very successful and you're getting lots of developers who want to use it. So you decide you're going to put an API on the front of it. So you can do something like api.example.com. So there's a service for dealing with API calls. It's basically built in such a way that it's going to help you write and manage API calls. It's called API Gateway. The way that works is you get your API calls come into API Gateway, and API Gateway has a bunch of rules inside, and it's listening to traffic coming in, and it can route the requests through the API Gateway to anything inside your ecosystem. So you could still take API requests and feed it into something in Kubernetes or Docker, and then get the response back, or it could go to any number of things. But one of the classic ways of dealing with this is serverless, which is using a thing called Lambda functions. So this is probably, in terms of that responsibility model, your life is going to get easier or harder depending on how you approach this. But essentially, it's functions as a service. So a Lambda function is something you write in a language of your choice. Classic ones are Go, Node, anything that's kind of server-side, Python. A Lambda function is a function that exists for a very short space of time. It's fired up on Amazon's architecture, so they will fire up a machine for you, take the function call, run it, get the result, and then send it back and then kill the machine. So these only exist for very, very small periods of time. Your job is to write the Lambda function and to make sure that the response is sensible. Amazon take care of everything else. So bear in mind that you have no control over that too. So you give up control, but you don't have to deal with it. You don't have to manage it. You don't have to worry that there will ever be a machine there. There will be a machine there that will answer that call for you. But writing Lambda functions is a bit of a head spinner. In fact, no, writing them is fine. Debugging them is a total pain, but that's a different story. But they are useful. They're a bit like glue. They're one of these things where you can sort of put Lambda functions in amongst the rest of your architecture to do odd things, like kind of stuff you would use cron jobs for. Same kind of thing like that. Little odd tasks that join one service to another service. And they're also quite addictive. They're a bit like tattoos. If you've got one, you kind of want 10, you know, so they're really good fun. But once you've got your head around it, it's very, very useful. There's a certain problem in them being short-lived functions in that they're very tricky to debug because their uptime is very short. So there's a bunch of other tools that grow around that to help you to debug them. But essentially, yeah, API call comes in here. The Lambda function fulfills the call, which basically runs the function. It can be connected to, you know, it could run off, get a bit of data, do a bit of munging on that, you know, rewrite it, send it back, and then your call comes back out through the API gateway. There are a thing called step functions as well, which allows you to sort of add a little bit of logic and to do this, do this, do this. You can have, whereas Lambdas are a bit of a one-hit, step functions allow you to have a bit of a process for it. And the final sort of bit of trippy levels of forgot the name of the movie, the one where it's just levels of insanity. But essentially, Fargate is a way of, it's a managed way of running containers as a bit like Lambda. So they would fire up a Docker container, run the contents of that, and then shoot back the results. So yeah, you need to sort of get your head around some of this. There's so many levels of abstraction, but the point is really that there's tons and tons of interesting tools. There's loads of ways to wire it up, and it really is down to you as a developer to decide what level of control you need and what responsibilities, what you want to care about as well, and what you don't want to care about. And you can piece all of these tools together because they're modular. I think that's probably enough for now. Your bingo card is probably full.
Awesome.
So there's more there. Okay, so that's a lot of ground we covered very, very quickly. Hopefully some of that made sense. And if you've got any questions, I'm happy to jump on them.